Most likely all your life you've been graphing on a coordinate plane like this. This is known as the rectangular grid, and we graph in terms of x and y. Starting with our x value, going up to our y value, we can plot points on this such graph. But what they never told you was there's a second type of grid we can use called the polar grid. And as a replacement to using x and y coordinates, this graph utilizes the angle and the radius. Let's start by looking at what an angle means on the polar grid. Just like you've done before, we can start at 0 and move counterclockwise all the way around to 2 pi or 360 degrees. We're just going to work with radians rather than degrees for now. If you moved up to pi over 2, that would represent this entire line here. If you moved to 5 pi over 6, that would represent this line here. 4 pi over 3 would represent this line here, etc., etc. Instead of the x and y axis, we always start on the polar axis, which is this line here at 0 degrees. The radius is always going to be the distance from our pole. The pole is basically the origin. The distance from the pole to each of these circles surrounding the pole represents the radius. For example, this circle would have a radius of 1. This circle would have a radius of 2. This circle a radius of 3, etc., etc. Polar coordinates are written very similar to rectangular coordinates, but instead of x comma y, we use the radius comma the angle or r theta. Let's try to graph some points on the grid. Here we have the point 2 pi over 6. I always start by finding my angle. Here's my pi over 6 line, and I know my radius is going to be 2, so I move 2 tick marks away. That's going to be 1, 2, and we're going to get a point right here with a radius of 2 on the line pi over 6. Let's try 2 pi over 3. First, finding 2 pi over 3, that's going to be all the way over here on this line, and my radius is 4. 1, 2, 3, 4, so my point's going to be right there. And there we are. Alright, here we have the point -3 pi over 2. We're going to treat this negative a little bit differently, and you'll see that. But first, let's find our theta of pi over 2. That's going to be this line up here. Now, instead of moving 3 spaces towards that pi over 2 on that pi over 2 line, since it's negative, we're going to go in the opposite direction. That's going to be, instead of straight up, it's going to be straight down. 1, 2, 3. And our point's going to be right here. Here we've got the point 5, negative pi over 6. Alright, remember what we do with negative angles. We just go in the opposite direction. So negative pi over 6 is going to be pi over 6 clockwise, or this line right here. Then our radius is 5. 1, 2, 3, 4, 5. And there's our point. On the polar grid, there are many different ways to write one single point. Here we have the point 4 pi over 2. Up to our angle of pi over 2 and a space of 4 away from the pole. Now watch what happens if we graph the point -4 3 pi over 2. Our angle of 3 pi over 2 is going to be all the way around this way. Now, since we have a radius of -4, we're going to go in the opposite direction, which would be 1, 2, 3, 4, right back at the same point 4 pi over 2. So these two different coordinates represent this same point. But wait, there's more. What if we graph the point 4 5 pi over 2? 5 pi over 2 would be all the way around once, and then 1 extra pi over 2. This pi over 2 is equal to 5 pi over 2, and a radius of 4 would bring us right to here. Same thing with 7 pi over 2, -4. 7 pi over 2 would go all the way around, back down to here, and a -4 would bring us right back over to here. So keep in mind, we can write a single point on the coordinate plane in many different ways. Last up is polar equations. These are going to be written in the form of r equals or theta equals, talking about what your radius equals or what your angle equals. The easiest way to explain these is just to do some examples. So let's do that. First, graphing r equals 3. This is basically saying where on this grid is there a radius of 3, which is actually just anywhere that's 3 spaces away. So what you're going to see is you're going to get a circle all the way along this whole area. Now each of these spots has a radius of 3 away from the center. If we wanted to graph r equals 5, same thing, find out where the radius is equal to 5, and that's going to be a circle all the way around as well, like so. What about r equals -1.5? Well, in the case of polar grids, your negative radius is basically the same as your radius, just for a different angle. So if we wanted to graph negative 1.5 as our angle, it's going to be the same as the radius of 1.5, which would be right around here. Whenever you have a theta equals equation, you're going to end up with a line rather than a circle. Here we have theta equals 0. Our angle of 0 lies along this whole line with both positive and negative values. So that's going to be a line right on that theta line, just like this. If we had theta equals pi over 3, it's going to be the same thing, a line right across this pi over 3 line. And there it is. Let's not forget about our negative angles. Here we have theta equals negative 7 pi over 6. This is just going to be in the opposite direction of 7 pi over 6, which will bring us right to here. And we've got our line.